Now in this problem, solving for log, it's a little bit more difficult. First thing we have to recognize is there's a property that says this. If you have log of m times n, the same as log of m plus log of n. We're actually going to go this direction. So if you get two logs being added together, it doesn't matter what the base is, you can combine them together as one single log by using multiplication. So it's going to be x times x minus 21 equals 2. Now this log, if you don't see a base, the base is always understood to be 10. It's called the common log. So now I'm going to convert to exponential form using the definition. Start the base, 10. Logs are exponents, so the exponent becomes 2. And that equals x times x minus 21. Now the reason why it's more difficult is because of what's going to happen next. 10 squared is 100. X times x is x squared. X times minus 21 is minus 21x. You have a quadratic. Anytime you have a quadratic, you have to get it equal to 0. So I'm going to subtract 100, because 100 minus 100 is 0. And we have a quadratic equation that we have to solve. Now you can use the quadratic formula. You can factor if it factors. This one will factor, but you can use the quadratic formula. I'm going to show you what I might do if it were me, and I'm not sure how to do either one of those. First off, use the quadratic formula if you know how to. But I'm going to graph it first. Let's graph x squared minus 21x minus 100 and graph. Oh, my window's messed up, so I'm waiting for it to stop graphing. I'm going to hit zoom 6, which fixes my window. So it looks like it crosses the x-axis maybe more than once. If I hit zoom fit, let's see if I can find the other one. So it crosses there, and it's probably going to cross somewhere way over there. So what I'm going to do is I'm just going to change my x max and my x min to like, I'm going to keep it negative 10, and I'm going to change that to like 50. And let's just count by 5s or something. I'm going to change these back to negative 10 and 10. Because I don't really care how low. I'm just worried about the x-axis. Cross there, cross there. So, these are count by 5s. So there's a couple ways I can do this. One thing is I can look at the table, and if I see anywhere where there's a y value of 0, that's going to help me out a lot. So let's go back to my graph. Since I'm counting by 5s, because that's what my scale was 5s, looks like it could be negative 5, 5, 10, 15, could be positive 25. Let's just go to the table and just see what happens. Well, it's negative 4. So we got a one value there, negative 4. So let's go way on down to 25. There's a shortcut way of doing this, but I just do this. Oh, 25. So there's my two possible answers. How you like that? Huh? You could also use the quadratic formula or factoring, but hey, I can use my calculator also. Sometimes it'll help me find it. If the numbers are even ugly, sometimes I can still find it. Now the only thing is if I take my original equation, log of x, if I put a negative 4 in there, watch, log of negative 4, I get an error. You can't take the log of a negative number. So that means is x equals 25 is my only solution.